This video is prepared to address the concern of a reviewer. Our argument is that it is impossible to evaporate, and this video has two parts. In the first part, we will demonstrate that even though we apply 10 to the power 9 times more or 10 billion times more power from the function generator, the solution will not evaporate, and it is impossible to evaporate. And in the second phase of this video, we will demonstrate that the technology associated with protein evaporation is very delicate, and for the last couple of decades, pulsed laser deposition technique has been developed, which requires extreme environmental conditions to safely evaporate microtubule. Otherwise, it will just burn on the surface. So here you can see, here is the function generator. We are applying 10 voltage PP, which we normally apply only a few microvolt, and this is the frequency 3.7 megahertz. So you can imagine that it's a 50 ohm output, so you can imagine that a huge amount of power will be dropped, approximately from milliwatts will be dropped into the, will be passed on the chip, and we will do this, and we have put lots of solution on that, and as you can see that we are applying, there is no sign of evaporation. We could keep it for hours, whole days and nights, and there will be no changes. And we have carried out other experiments during this time, spectroscopic experiments, which shows constant output of emissions. That means there is no material loss whatsoever during this experiment. And also you can see that the film absolutely does not dries up, and we can keep the camera like this for hours, and we would like to suggest that if we switch on the mobile phone, then 2000 microwatt power, or approximately 2.2 milliwatt power, enters into our ears, and if somebody switches on mobile phone and exposes it to water, then they can understand whether it comes out or not. So normally protein is a linear chain folded into secondary structures, and it is a very, very delicate thing to evaporate. Normally, if we pass a few watts of power supply to this tubulin solution, there will be no change in the absorption quantitative absorption of the solution, and there are several ways we can prove that there cannot be any evaporation. So you can see that the water droplet, which was a big droplet, instead of film we created a big droplet here. There is no change in the droplet configuration, and if you see that we are applying a huge voltage, that is 10 billion times more than that we apply. So it is just impossible for the solution to evaporate, or buffer solution to evaporate. So it is mainly water over there, and you can see we can keep it for hours. And also this experiment is possible to do in every laboratories. We have just connected two cables from the function generator, and this could be, we could keep the camera hold for hours, but we don't need to do that. If we make a simple calculation, we can understand that this is not possible. Many people around the world, they calculate the total current sent to the solution and convert that into energy. Actually, we should calculate the temperature rise of the solution, only what amount of energy the solution absorbs. For an example, in this particular case, if entire energy is not absorbed by the solvent, so it never gets into that high temperature. But of course, if we see that we are applying a few milliwatts, if the entire energy is absorbed by the water molecule, temperature will be more than the sun, more than 5000 Kelvin. But it never happens anywhere in the world. Whatever current we are supplying to any device, that doesn't mean that we can burn the solution. The kind of power that we are supplying now, which is more than 10 billion times than hour, much more than that values are applied to the microtubule solution, and standard literatures exist where you can see that this kind of high electric field is applied and AC electric field is applied to orient the microtubules and at a much lower frequency. So high current, sending high current to microtubule does not destroy the sample or the solution is already proved, and there exist several literatures in support of that. Now we would like to switch off this one because we think that it is enough evidence that the droplet that we kept there remains there, and this could be reproduced in any laboratory. The argument that solution evaporates and we measure the current flowing due to the ion motion is completely wrong. This can never happen, and we can cite at least a couple of thousand papers in which current calculation will demonstrate that temperature will be more than couple of thousands Kelvin, but it never happens because it always depends how much energy is absorbed by the material and not the total amount of current sent to the material. If we send 1 watt and we get output as 1 watt, that means no loss, temperature will remain constant. This is the machine using which one can evaporate from solution microtubule or DNA or other polymeric materials or proteins. So therefore we need an extreme environmental condition where pressure is 10 to the power minus 11 torr, which is 10 to the power 11 times lower than the normal atmospheric pressure, and in this environmental condition we use this particular setup to deposit the material. The material is pushed from nearly from this direction, and in this chamber the material is evaporated, and it needs to be cooled down nearly at a very, very low temperature so that the microtubule or the polymeric material is not destroyed or burned. Therefore, not only the temperature needs to be cooled down, the evaporation condition is liquid and extremely low atmospheric pressure is essential. Therefore, we conclude that to safely evaporate microtubule is not easy from the solution. If we try to heat up the solution will be burnt and microtubule will be burnt, but it will never ever leave the solution and get evaporated out. Those molecules evaporate, which are very, very small molecules in size, and they also evaporate under UHB conditions. And if we do it in the room temperature, and room temperature if we try to burn, it is impossible to evaporate